Hi everyone, in this video I want to discuss about the recently released Cloudera Flow Management Kubernetes operator, which is basically an operator provided by Cloudera to run NiFi on Kubernetes on your Kubernetes clusters. I just want to go through the steps of deploying everything and show a few features and discuss about the advantages of running NiFi on Kubernetes and so on. I already did a couple of webinars and videos around it, but I really just want to go through all of the steps in terms of installation, deployment, and so on, and then discuss a bit about NiFi on Kubernetes. So here in this case, I have an OpenShift cluster deployed on AWS, and that's what I'm going to use today for the demo. So I'm connected to it. I'm using the K9S console to look at what's deployed there. And that's really where I'm going to deploy everything. So the first step here, and this is the only requirement for the operator, is to have Cert Manager deployed. Cert Manager needs to be installed and configured, and that's what will be used to provision the certificates on the fly for the resources that we will be deploying. So certificates for the NiFi clusters and the NiFi Registry instances. So that's really the only requirement. We have it here deployed, you can see, and that's what we will be using when deploying the resources to have everything secured. Okay, so now that this is done, I can switch over to my console and I will start doing things on my OpenShift cluster to deploy things. So the first step is really to deploy the operator. So I will create a namespace for that specific operator where I will be deploying things. And then I want to add for that namespace a secret with my credentials to access the binaries that Cloudera is providing. So I'm here adding my secret to access the container repository of Cloudera. So once I have this secret available, I'm going to use the CFM CTL tool that Cloudera is providing. This is a binary that you can get from the archive Cloudera website, where all of the binaries are made available. Once you have downloaded it and like installed it on your laptop or machine from where you are doing all of those steps, you can just use it. And this is basically a CLI helping you with the deployment of everything. So here, there is a command that I can run to check that everything is ready for installing the operator. So I'm checking that everything is set up correctly to access Kubernetes, that the Cert Manager dependency is installed, and that we don't have things there that would be causing any issues. So here we can see everything is available. That's great. And then we can run the install. So to run the install command, you will need to provide a license file. So a license file is given to you by Cloudera when you are subscribing to the Cloudera products, or if you are subscribing for a trial version. So you need this license file for the operator to work. So in this case, I would give this license file in my commands. You can see that I'm referencing the container repository of Cloudera and I'm specifying the version, this one being the latest at the moment I'm recording this video. So I'm going to run this, and the operator is going to process with the installation. If I switch over to K9S, I will see things here, and the operator is being deployed. This is going to pull the images from the container repository and install and deploy and run the operator. So after a few seconds, everything is up and running, and the operator is ready to receive requests to actually deploy resources. So here, my operator is running. Everything is looking good. Deployment is successful. Okay, so once this is done, I'm going to create a namespace for deploying my NiFi cluster, because in this model, every NiFi cluster will have its own namespace. We don't want to deploy multiple resources in the same namespace. So here I'm creating a namespace specifically for this deployment, Cloudera NiFi demo. And for that namespace, I'm going to, again, create a secret with my credentials to access the container repository to pull the container images. So that's the first thing that I'm doing. And then I'm going to use an LDAP instance for my users and groups for accessing the NiFi UI. So I'm also going to add a secret for the, let's say, the admin user that is going to be accessed, that is going to be used to access the LDAP instance. So here I'm creating a secret where I'm adding the password of my admin user. And finally, I'm also adding another secret that I will be using. This is the key that I'm using for encrypting the sensitive properties in the flow definition. So any sensitive value that you use when you are designing a flow will be encrypted. And this is the key that is used. And why do I need to specify that key? It's because this key needs to be the same across the nodes. To make sure that things are properly managed when scaling up and down, I'm going to set it specifically in the NiFi configuration, because if I'm not doing it, when NiFi is starting for the first time, a random value will be generated. So I'm adding this as a secret, and I will be able to reference it in my file. Okay, so now that I have this, I can specify my YAML configuration file for specifying the deployments that I want to do here. So I'm creating a NiFi YAML file, and this is what it looks like. So I'm going to go through it and explain quickly what this is about. So the beginning, the namespace in which this is going to be deployed, the name for my deployment, number of replicas is the number of nodes that I want for my NiFi cluster initially. The references to the images where I'm using the secrets that I created just before. Then I have some configuration for storage, where I'm saying that by default, every repository should be 10 gigs and using GP3 for the storage class, which is a storage class that already exists on my Kubernetes cluster. And I'm just overriding saying that for content repo, I want 50 gigs instead of 10. I can override for every repository that NiFi is using, obviously. For security, I'm specifying everything here for LDAP access. There is the reference to my secret here, and that's what I'm going to use to access my LDAP server. I'm specifying the initial admin, so that's the only user that will be able to access the NiFi UI initially after NiFi is deployed, and go in there and set up the policies for more users to have access to the UI. So this initial admin identity is very important. I'm specifying the reference to Cert Manager to get my certificates issued. In this case, I'm using a self-signed CA. Then here for the host name, this is something that I'm specifying by giving a name that I want to use, and OpenShift will take care of creating the route and provide access to the UI through this endpoint. So you can see here after that I'm specifying a route with a client IP for session affinity. Here I'm specifying the key for the sensitive properties encryption. You can see here that I can override some of the configuration for NiFi. So here in this case, I'm saying that leader election is done using Kubernetes. A bit further down, you can see here that for the state management, I'm also using Kubernetes. Thanks to those two properties, it means that I don't need Zookeeper anymore when deploying NiFi. So those deployments, those NiFi deployments are going to be Zookeeper-less, and I don't need Zookeeper for running NiFi. So that's very nice, because it's making all of those deployments smaller in terms of resources consumption. I can override how much heap is going to be allocated to NiFi, and then I can specify the resources that I want for the NiFi container. So here in this case, I'm saying that I want 3 cores, 6 gigs of memory for my containers, and the log container is something very specific to logs collection. And that's why the amount of resources is negligible here. So that's what I have for my NiFi YAML file. Everything is very extensively documented in the Cloudera documentation. So now I can just apply and deploy this. So here, if I switch over to K9S, here I will see that the file has been submitted to the operator, and now I have my cluster being provisioned. So it's going to take a couple of minutes to download the container images and to have everything running. So I will wait a bit, but while this is doing its magic, we can look into the pod and see all of the containers. So we have containers for the logs, and then there is the actual NiFi container. This one is taking a bit longer to start because we are actually waiting for NiFi to be starting. Okay, so while this is starting, I will directly go to the steps for deploying NiFi Registry. So very similarly, I want to create a namespace for the NiFi Registry. In that namespace, I want to create a secret for pulling the images. And then I want to also add a secret for LDAP. And then I want to deploy my NiFi registry. So if we look at the file, very straightforward. So we have same namespace, name of my NiFi registry instance, references to the images, my name for the endpoint that is going to be provisioned by OpenShift with a route to access the NiFi registry UI, initial admin, cert manager column reference, LDAP, and that's it with my all of the information to access LDAP. And that's it. NiFi registry is more straightforward. So I can just go ahead and apply this file. And if I switch over to K9S, we can see here that NiFi registry is being deployed. Okay, so once we have this, we can now go over to directly access the UI. So here I have the interface for my OpenShift cluster, but I will open a new tab and I will be able to directly access the endpoints that I specified. And I just need to add /NiFi at the end. Obviously, since I'm using self-signed CA, I need to accept those certificates. Once I'm in the UI, I will need to authenticate with my initial admin. And I access the UI. As you can see, no policies are set at this point. So that's the first step that I will need to be doing, right? So I will need to grant myself some policies. So I will go ahead and do that. So for example, here, I will go to grant me access to system diagnostic here. So that here, if I go to cluster, I can look at my nodes and see what's going on. So I have my 3 nodes, 3 cores. That's what I want. The GVM here with the amount of heap that is provisioned 2 gigs. That's what we said. Flow file storage, 10 gigs, content storage, 50 gigs, provenance storage, 10 gigs. And version, we can see here we are running NiFi 125 with Java 11. We also have images from NiFi 2.0 milestone release. So it's also an option to use NiFi 2 already with this operator if you want. So I will also grant myself some permissions here because otherwise it's not really great. So I'm going to give me read access to the root process group and then write access to the root process group. And also view the data because I will be showing a few things and then modify the data here. And I also need to add the nodes here. And we are good. So I think that's all I need. Now I can switch over to NiFi Registry here. So same story. I have this endpoint. I can access here. And I can access with the initial admin. So same story here. I'm logging in, I'm logged in, and then I can go in there and create a bucket, demo if I want to. But in users, I will need to add a user that is representing the nodes of my NiFi cluster. So in this case, the way this is working, you need to do this syntax, cn equal the name of your cluster as specified in your resource file, YAML file, and all cluster node. So you add this node, and this node should have read access to the buckets and proxy user requests. Okay, close here. And then on the buckets, here I want to give access to my NiFi admin user with all permissions, because that's the user I'm connected with in the NiFi UI. But obviously here you would likely prefer to have group-based policies. Okay, so once I have this here, I can go back to NiFi here. I can go into the controller settings, and I can add a registry client. So here I can add a registry client. I want to add NiFi registry clients, and the endpoint is going to be this here. Sorry, so NiFi registry here. And here, if I connect here, I'm going to say this endpoint here. And I'm using the internal endpoint so that the traffic is always staying inside of the cluster. Okay, so update, and that's it. And now I can create a process group here. My flow, for example, here, go inside of that process group, and let's say generate flow file and update attributes here. Connect the two together. And here I will auto-terminate this relationship, and that's it. I have my flow. So on the process group, I can say start version control. Here I can see the bucket that I created, so I can give this a name, my flow gf to update attributes initial version. And save. And if I go back to the NiFi registry, now I have my flow here that is versions, and I can create multiple versions and so on. So that's it. I have my NiFi deployed. I have my NiFi registry instance. Everything is looking good. Now I want to play with it and look at things, how things are working. So the first thing I want to show you is scaling down. Okay, so obviously you can very easily do a manual scale up and scale down. So I'm going to run this once. I have 3 flow files, and okay, so there is a policy missing. That's what I was. Here we want to also add the node here. Okay. So here we see the flow files, and we can see here that we have 1 flow file per node. Okay, 3 nodes, 3 flow files, because this processor is running on all nodes. Okay, so now if I go back here and I edit my NiFi YAML file, and I say, okay, let's scale down to 2 nodes, I can just do a manual edit like this and apply again. And this is going to scale down things. Okay, so if I go back here, and if I go in the cluster view, we'll see that, okay, unfortunately, I'm on the node that is being disconnected. So I will need to wait for OpenShift to move me over to the other node. But what's happening, I'm not looking on this one, but what's happening is that the node is being disconnected from the cluster and then offloaded, which means that the data that is on that node is going to be moved over to the remaining nodes in the cluster. And then the node is finally removed. So that's what happened. Unfortunately, the route was sending me to the node that has been removed. But if I connect again to another node, now I have 2 nodes in my cluster, but I still have 3 flow files. And we can see here that the flow file that was on the node 2 has been moved to the node 0. So that's what is happening here. So obviously scaling down is not creating any kind of data loss. Okay, so now something that I want to show is what is happening if a node is dying. Really something that is not clean because of some error or something like that. So in that case, in a traditional NiFi cluster, that is kind of annoying because the in-flight data that is on that node when the node is going down will be stuck until the node is back up and running. With NiFi on Kubernetes, this is great because if a node is going down, Kubernetes will detect it, will create a new node, and will move the volumes that were attached to the dead node to the new node, which means that in a few seconds, the data that is in flight is still being processed. So there is no interruption in the processing of the data. This is really helping with this. So I will just check here and I will kill. So here, this is actually my NiFi. And I'm going to kill the 1 0. Sorry, the namespace is not my NiFi. So 1 second. Here it's Cloudera NiFi demo. So here. Okay, and I want to delete that node. So it's going to be a delete of the node 0 right now. So hopefully I'm not in the UI, I'm not on that node, but let's see. Okay. So let's delete and switch over here. So if I refresh, well, you can see it's not working. So I was not lucky. I was on node 0. So I'm going to wait a bit, but basically, if I move over to here, the node has been deleted, and you can see Kubernetes is creating a new one automatically, and the operator is going to take care of moving the volumes. Okay, so here I was not lucky. Here I'm not able to connect anymore, so the route is going to redirect me when OpenShift is going to detect things, or just wait for the node to be back up again. So let's give it a minute. Okay, so here again, I'm back to my cluster. You can see that for now, the node is not back and my data is unavailable. But very quickly, the node is back up and running and the volumes were moved to the new node and my data is preserved. So in a few seconds, even if a NiFi node went down, I was able to recover and processing is still going to happen. So in this case here, a node went down. This is just the UI, the connection with the clustering that needs to be refreshed. So let's give it a few seconds, but you can see the cluster is back to 2 nodes. I can actually go back here in the cluster. The node is not connected. Okay, so it's still joining back the cluster. So let's give it a second. While this is doing its thing to reconcile the cluster, there is also obviously a case where you want to use automatic autoscaling. So in this case, you will use HPA, Horizontal Pod Autoscaler. And you can obviously use that as well to manage the autoscaling of your cluster up and down. So just Okay, so let's check what's happening here. If I go into the NiFi logs here, that's not what I want here. So the heartbeat is correct and sent. So this one is okay, and this one is also fine. So everything's fine, and the cluster is fine. Okay, so I was not just patient enough. So now, as I was saying, you may want to configure HPA, so an autoscaler. So in this case, here, we can create a file, HPA, which is specifying what I want for the autoscaling. So here I'm saying based on resources utilization, CPU-wise, and using the threshold 75%, I can go up to 5 nodes and down to 1 node, depending on my resources and utilization. And then I'm saying that I want a stabilization window of 30 seconds before I'm taking actions. By default, it's 5 minutes, and the default of 5 minutes is probably better. But in this case, for the demo, I want things to happen quickly. So I'm using 30 seconds here. Okay. So I will apply the HPA. And if I go back to my K9S and move to this, I can look at here and see what's happening. So it's going to look at my cluster and look at the resources and the amount of resources being used and take decision. So here it's saying that right now here I have 2 and desired is 2. It's going to look at the resources and take decisions. So since my nodes are not doing anything, it's going to take the decision that I should be scaling down. So if we look at the cluster view and I go to system, we can see here that the load average is very low for the nodes. So it's going to scale down to 1 node. And that's what is happening right now. So I've been, again, on the wrong node. I've been disconnected. I'm on the node that has been disconnected and the node that is going to be removed. We can see that this data is offloaded to the cluster. And the node I'm currently connected to is going to be removed. So that's it. And the route is now going to move me to the other nodes, to which I need to connect again. Now I have a single node cluster because of my autoscaler. Okay. So now we will try to scale up by simulating resources consumption on the node. Okay, so we have our 1 node cluster, and I'm going to simulate data here. So let's do it. I'm just going to start this. It's going to just remove the data. Very simple. And in the generate flow file, I'm just going to say, okay, let's create files of 100 bytes. Let's say unique flow files so that it's a bit more intense in terms of generating the data. That's it. And I can actually, since we have 3 calls per node, let's say 3 concurrent tasks to really use as much CPU as we can. So I apply this and I start. So I'm going to generate a lot of data, as we can see here. Oh, I forgot to change something. Scheduling. Because if we do 1 file per minute, it's not going to be very interesting. So let's do 1 file per millisecond, and let's start this. So, okay, so now we can see that we are generating a lot of data, and the data is being dropped immediately. So now if I look at the cluster view, I will see that in system, the load average is going to increase. So it needs probably some time to adjust, but I should see the load average increasing quite a bit. It sounds like I'm doing something that is not enough. So let's be a bit more intense. And let's do 0 milliseconds and 6 concurrent tasks. And let's start this. Okay, so generating a bunch of data. And I'm also going to stop this. And here also put, let's say, 10 concurrent tasks. It's not really making any sense, but it's just to have the data removed. Okay, so now if I switch over to here, we can see that we are using a lot of CPU. So you can see now that we want to have 2 nodes. So it's actually going to scale up. So here, very quickly, I will see another node, and now I am at 2 nodes in the cluster. So it's scaling up fairly quickly. So we can see here that we have a built-in saying that the node, a new node connected, new node, NiFi 1. So here we are generating still a lot of data. And if I go back here, we can see that CPU is still very high. The reason is that every node that I'm adding is also going to do the same work. So every node is going to be extremely active with a lot of processing. So in the end, very quickly, in a few minutes, we are going to scale up to the maximum number, which is 5. So I'm not going to wait for that. I'm just going to wait for scaling. You can see here that we are now scaling to 4 because I'm at 200% of the target. So I'm going to scale up to 4 directly. So you can see here that now this is saying that the new size should be 4, and we are now at 4 pods. And if I go back here, and the route probably switch me to another node. So let's just connect again. Here. So if I connect again here, I will have my 4 nodes cluster working and processing a lot of data. So actually, I'm at 3 nodes for now and 4 nodes. So now I have my 4 nodes. If I wait just a bit, I will obviously go very quickly to 5 nodes. Let's not do that. I'm going to stop the generate flow file. I will stop the update attributes here. I will just restart the generate flow file very quickly just to have some data here. So we can see that the back pressure is a soft threshold. So we are actually a bit above the back pressure here. So that's great, but now there is no processing anymore. So if I go back here, quite quickly, the CPU usage is going to go down. So it just needs to be reflected. We need to wait a bit. You can see it's going down. And fairly quickly, we are going to scale down the number of nodes. So let's wait a bit. But that's really one of the advantages of running NiFi on Kubernetes. If you have very elastic workloads, such as logs processing, things that are going to change over time during the day, because maybe you will have more data during the day and less data during the night. That is very common examples where having NiFi on Kubernetes is extremely interesting. If you have NiFi consuming from a Kafka cluster, for example, depending on the amount of data, then that's something that we want to have elasticity. So in this case, we can see that because we went down in terms of CPU consumption, we are offloading and going back to just one node in the cluster. So here again, I need to go back to the right node because I was on a node that has been removed. So if I connect again here, I'm back to my NiFi cluster. And we can see here that I have just one node and I have all of my flow files. So all of the data has been properly offloaded off my nodes to the only node remaining in my cluster. And that's really what I wanted to show. So the automatic auto-scaling, the processing of the data that is in flight in case you are losing a node, how you can scale up and down without losing any kind of data, and how to install the operator, how to deploy resources, and all of those things, connecting to the NiFi registry, using the NiFi registry for version control of your flows and checking out the flows. So once you have all of this, obviously it's very easy to use the CLI or the APIs exposed by NiFi and NiFi registry to really see all of this in a very automated / on-demand way, where you could go to the point where you are actually scheduling things. If you have more like batch-oriented workloads, you could say, okay, deploy a NiFi cluster on my Kubernetes cluster, check out this flow, run the flow, and when there is no more flow file in the flow, it means that the processing has been done and I can shut down everything. So very nice usage of everything. So I think what happened here is maybe for some reason, I'm just checking, but my feeling is that maybe yeah, we for a short time we scaled up again. So now things are stable, and I have my one node, everything is in place. So that's it. That's really what I wanted to show you. Better managing the UI access when you have all of those operations of scaling up and down is something that Cloudera is working on to make it better. But that's what is available as of today. So I hope it was useful. I thank you for watching this video, and I'll see you next time.